Welcome student. Last two video I discussing the acid base titration and redox titration. Now in this video I discussing the precipitation titration. Which titration to form the precipitation? That titration is called as precipitation titration. In this titration, the end point of in this titration does not be determined by ordinary indicator method. That's why the end point of this precipitation titration can be determined by potentiometric method. For example, titration between AgNO3 versus KCl. Titration between AgNO3 versus KCl. AgNO3 is the pipette solution. AgNO3 is the pipette out, and KCl solution is the broad solution. KCl is the broad solution. KCl is the broad solution. In this titration, during this titration, to use the silver electrode is used as indicator electrode. In this titration, silver electrode is used as indicator electrode. Same like this, you already known that Kuhn hydron electrode, hydrogen gas electrode. This is the indicator electrode. That same that silver electrode is used as a indicator electrode in this precipitation titration. Precipitation titration. Then this is coupled with saturated calomel electrode with KNO3 salt bridge. With KNO3 salt bridge. See diagrammatically, pipette out a AgNO3 solution. Pipette out a AgNO3 solution. AgNO3 solution. In this solution is used as the silver electrode is a indicated electrode. Silver electrode is the indicator electrode. Silver electrode is as the indicator electrode. In this electrode is coupled with another electrode is called as saturated calomel electrode. Saturated calomel electrode. This is the saturated calomel electrode through KNO3 salt bridge. Through KNO3 salt bridge. This AgNO3 solution. In this solution, dipped silver electrode is used as the indicator electrode, and this electrode is coupled with another electrode is saturated calomel electrode. This saturated calomel electrode is the reference electrode, and this both electrodes are coupled with each other by using KNO3 salt bridge. KNO3 salt bridge. KNO3 salt bridge. This is the diagrammatical. Then how to representation of this electrode? See, Hg minus Hg2Cl Hg2Cl solution, then KCl solution, salt solution. Double line is the salt bridge. Used as salt bridge, KNO3 salt bridge. KNO3 salt bridge. And again AgNO3 solution. AgNO3 solution and silver electrode. And silver. This is the representation of this electrode. Hg, then Hg2Cl, KCl solution, and AgNO3 and silver electrode is the indicator electrode. Then initially EMF is measured by potentiometer. In this solution, EMF is measured by potentiometer. In this titration, the reaction is carried out. Ag plus in this titration reaction is carried out, and Ag plus ions are precipitate. Ag plus ions are precipitated as a AgCl. In this titration, Ag plus ions are precipitated to form AgCl, AgCl salt, AgCl salt. See, Ag plus NO3 minus plus K plus Cl minus gives AgCl plus K plus and NO3 minus NO3. This reaction is carried out in this titration. Means these silver ions are precipitated as a AgCl salt. Silver electrode precipitated as the AgCl means this Ag plus ions are react with this Cl minus ion to form the AgCl. This is the precipitate form in this precipitation titration. This AgCl precipitation form in this titration. In this titration, this is the Ag plus are the positive electrode. That's why this electrode is take the reduction reaction. Ag plus ions are take the reduction reaction. See, Ag plus electron minus gives Ag, gives Ag means this is the reduction take place. This is the reduction take place. This is the reduction takes place. In this titration to form the Ag plus ions are formed to precipitate AgCl. That's why this titration is called as precipitation titration. The which titration? AgNO3 versus KCl. KCl is the Bird solution. KCl is the Bird solution. In this titration, Ag plus ions to precipitate form the AgCl. AgCl. That's why Ag plus electrode gives the reduction take place. Gives the reduction take place. In this reaction, how to write the reaction question? QA. Already known that QA is the reaction question. See, activity of product and activity of reactant. This is the reaction question. Activity of product and activity of reactant. Activity of product is activity of Ag upon activity of Ag plus ions. That's why 1 upon activity of Ag plus 1 upon activity of Ag plus ions. Then how to write the Nernst equation? Nernst equation of in this reaction. Nernst equation of in this reaction. See, EMF of silver electrode, EMF of silver electrode or cell potential of silver electrode is equal to standard cell potential of silver electrode minus 0.0591 upon n log of QA. Log of QA. QA is the reaction quotient. That's why E0Ag minus 0.0591 upon n log of reaction quotient means 1 upon Ag plus ions. 1 upon Ag plus ions. Therefore, n is equal to 1. N is the number of electrons take part in the reduction or oxidation. N is the number of electrons take part in the reduction or oxidation. In this reaction, only one electron is take part. That's why n is equal to 1. That's why n is equal to 1. Then last equation is equal to E0Ag minus E0Ag minus 0.0591 log of activity of Ag plus ions. This is the minus sign converted into positive. That's why this Ag plus ions going to the numerator. That's why E0 cell potential of silver electrode is the standard cell potential of silver electrode plus 0.0591 log of activity of silver electrode. Log of activity of silver ions. This is the calculate the EMF of this silver electrode. Calculate the EMF or cell potential of this silver electrode. means this equation used to determine the cell potential of silver electrode. Cell potential of silver electrode. Then in in this titration, how to reaction take place? How to reaction? During this titration, in beaker having Ag plus ions and NO3 minus ions. NO3 minus ions. During this titration, Ag plus ions are decreased because reduction take place. Because reduction take place. Already told that Ag plus electron gives Ag. In this titration, this Ag plus ions are decreased. Ag plus ions are decreased. The EMF of any solution depends on the concentration of ions present in the solution. Already you know that EMF of any solution, EMF of any solution depends on depends on concentration of ions. Concentration of ions means EMF or cell potential of any electrode depends on concentration of ions present in the solution. Concentration of ions present in the solution. During this titration, in this solution, Ag plus ions are decreased because this Ag plus ions are reduction take place. That's why in this solution, during the titration, whenever the addition of KCl, during the titration, whenever the addition of KCl, this Ag plus Cl minus gives AgCl, that's why this in this solution, whenever the addition of KCl, this K plus Ag plus and Cl minus ions react to each other to form AgCl, then already to decrease the Ag plus ions. During this titration, this Ag plus ions react with Cl minus ion, then decrease the Ag plus ions in this solution. That's why EMF of this titration is as well as decrease, because EMF of any solution depends on the concentration of ions present in the solution. Then Ag plus ions are decreased, as well as EMF of this solution is decrease. Then how to represent the graph? In this graph or in this titration, this is the EMF. Then volume of KCl, during this titration, whenever the addition of KCl, Ag plus ions react with the Cl minus to form the AgCl, as well as Ag plus ions are decreased. Then EMF of the solution is decreased initially. Then EMF is slowly decreased. Near the equivalence point, the EMF is sharply decreased. Near the equivalence point, EMF is sharply decreased. Then after the equivalence point, again EMF is slowly decreased. The Ag plus ions are decreased, EMF of the solutions are decreased. Near the equivalence point, the EMF is sharply decreased. This straight line of this graph is called as end point or equivalence point of titration. This is the classical method. To determine the end point of titration. Then how to determine the end point of analytical method? Say already you know that here delta E upon delta V, then volume of KCl. In this nature of the in this graph is like this. nature of the in this titration of the graph is like this. This is the end point of titration. This is the end point of titration. This is the analytical method. This is the analytical method to determine the end point of titration. This is the precipitation titration. During this titration, silver ions are decreased. Silver ions are decreased. Why decrease? Because Ag plus react with Cl minus ion to form the AgCl. As Ag plus ions are decreased, then Ag plus ions are decreased, EMF of the solution is decreased. EMF of the solution is decreased. This is the precipitation titration.